maybe I'm going to just quickly recap what I just said. So is it recording for everyone? Did you get the little notification? Hopefully it's working. And now, right. So I'm just going to recap this very quickly because we started recording now. What I did here is that I changed my working directory. I then double checked the working directory was the one I wanted. To have our data frame loaded to continue what we were doing last week, I used the function read CSV to work to load the feline data data set, which is a comma separated value file, which is in my working directory. So if you are having issues loading this, double check that you are working in the folder where you have saved this. If you can't find your file, maybe what I'll do is that I'm going to copy and paste the lines of code for you to generate that data frame again and then saved it. So that might actually be a good idea. Right, so if you do this, now I need to stop. No, sorry. Right, so if you do this, right, this is the first line of code is to create the data frame, and the second one is to write the CSV. So if you're struggling in loading your CSV file, just run the first line of code, which will create the same data set that I have, and hopefully that will be okay. If you want me to wait a bit as well for you, I can certainly do that. So just give me a shout. And then what I did is, so I loaded the data frame cats, and then I created a new vector called age, which is the age of the cats. And I wanted to bind that to the end of my data frame as a new column. So I used the function cbind, and I did cbind with cats and age. And what that returned, let's run that again. What that returned was my data frame cats as we had before, and then it added the column age to the end. What I was now saying is that you need to be careful with this because it does output the data frame cats with the age at the end, but it doesn't actually place it in your saved data set. So then I was demonstrating that by running cats again, and here is our original cat. So if you wanted to do this, you would have to attribute this to a new variable or replace the cats variable with this. So let's just save it as cats2, so we can have that with the new column. So, sorry, I was just double checking. They don't do this later on. I don't think they do this at all, so I want to do it just to show you. So cbind cats and age. And now the difference between this and this is that I'm now attributing that to a variable called cats2. So if I run that, I now have two data sets, cats2 that has 4 variables rather than 3. So that means that it has 4 columns. So let's have a look at cats2. And now it has saved the column age at the end of cats. So just wanted to give that that note, because sometimes you might think that you're adding something, but you're not unless you're saving it to a variable. So let's try and add and create an error where we're trying to add a column with the wrong number of values. So let's say I'm going to create an h2 vector, and I'm going to put the same values as before, 2, 3, and 5. And now I'm going to add a fourth value of 12. Okay, I'll run that. And now I'm going to try and do cbind of cats and h2. And this is going to give me an error. So let's have a look at the error. It says there's an error in this data frame, and then arguments imply differing number of rows, 3 and 4. So you went to the first argument we gave cbind, which is cats. It has 3 rows, and the second one has 4 rows. So what it's telling us here is that you can't combine the first object with the second because the second object has more rows than the first object. The same would happen if I had just two ages. So let's do age 3 just to show that. And now I'm just going to put 2 and 3. Okay. And now I'm going to do cbind of cats and age 3. And now again, it gave us the same error, but now it's saying that the first object has 3 rows and the second object has 2 rows. Right, are people okay now? Are there any questions, or is anyone still struggling getting cats up and running?
Joanna, I've got a big problem because I'm on a Mac and I can't access the working directory we had before. So I'm way behind. So I think rather than hold up the group, unless Lara can help me independently, I shall just have to follow the recording because I'm going to hold you all up.
I think I would rather just wait 5 minutes if the rest of the people don't really mind us waiting 5 minutes and we're trying to fix this, because I don't want to leave anyone behind.
Okay, that's appreciated. The issue I've got is the directory structure. It's impossible to find it on a Mac. So as a PC, you can just get your backslash. But I can't find where, so I can't load anything.
What I'm gonna try and do is change to would you mind sharing your screen? Is that okay?
Yeah, I've got 700 windows open, but
if not, it's okay. It's just, it might be easier for us to troubleshoot. I think this troubleshooting, like,
so
yeah,
okay, you can see that now?
Yes, I can.
So basically I'm trying to, so my my home directory is this, which is fine, but the problem is when I actually go and find it within the kind of Windows environment on the Mac, it's just impossible because it's not that. There's about 7 kind of layers before it. So
what you mean?
So I'm now, yeah, Carol.
So when I can see this might not be the problem, but when you're doing set WD here on the line 16, users
Yep.
with lowercase, whereas when you do get WD, users is with capital. So try that. I can't see the bottom of your screen, so I don't know if it worked.
I didn't have any problem with this last week, so I'm not entirely sure what's going on.
So would you mind maybe pulling the screen, pulling the RStudio and minimizing and then pulling it up, because I can't see the bottom. I can't see the error that it's giving you. Sorry.
What, in the console? Yeah. Hang on.
I'm sorry.
Can you see that now?
No, it's the bottom of the window that I can't see. It's kind of not adjusting. Do this. Click enter several times to pull the results up.
Sorry, do what? Sorry?
You can see it now. Sorry.
You can see it, or you can't? Is it actually a different window in Zoom?
The problem is that my Zoom kind of bottom banner is on the way, so I can't see the error you're getting.
Okay,
I think I can see it. If so, 1 second. If you press, or if you want, we can like go to another room and discuss this. I don't know if that would be better.
Do you know what the problem is, Lara?
I don't know, but what we can do was try the files tab, and then if we can like just go to the working directory by scrolling through the files, then maybe that's easier.
Let me stop.
Yeah, that would be easier. How do we do that?
Yeah, I think you need to stop sharing the screen, and then I can try and create a breakout room that I've never done before. Okay.
Let's see.
I don't think I know.
I don't think you have the power, no? Well,
no, I think because Debbie was the main.
But Debbie, if you can create a breakout room. Ah, perfect. Yeah, she just said it's fine.
Oh, Debbie's here. Okay, I didn't know she was here. Okay, I haven't seen it. Okay, so hopefully Debbie will send you Richard to the breakout room, and hopefully you can catch up when you come back. But let me know when you come back, and I can very quickly recap.
Okay, thank you.
Okay. Sorry, everyone. I just think that sometimes it's easier to show the errors because, one, I don't like to leave anyone behind because that's not the point really of the workshop. But second, if it's possible for us to troubleshoot together, then we all learn something, and you might actually encounter the same error as Richard later down the line, and then you remember how he solved it, or have some idea. For now, just continue. Now I need to find my. So yes, so I was showing how if you try to bind add columns with the wrong dimensions that don't the dimensions don't match your data frame, you're going to get an error. And by looking at the error, you can get an idea. By reading the error message, you can get an idea of what the problem is. Sometimes they're a bit cryptic, but actually more often than not, you'll get a bit of a clue of what the problem is. So what if, okay, we had a data set, let's say we have cats, but we don't remember what the number of the rows is. And actually in this made up scenario, the data frame is too big for me to go and count the rows, to just output it on the screen in the console and count the rows. So what's a good way to, I'm going to show you a couple of ways to look at the dimensions of a data frame. So the first good function to do this is dim, which stands for dimension, and then our data frame inside. If I run that, it gives me two numbers. And the first number is the number of rows, and the second number is the number of columns. So that's always the case. The rows come first, and then the columns. If I'm just interested in the number of rows, I can do n row cats. Okay, and that's 3. And if I just want to know the number of columns, I do n col cats. So these are 3 little functions I use all the time. They're very, very useful. So let's say I'm not sure how many rows there are. I do this, and then I can then bind whatever column I want to bind at the end. To have a look at the length of age, or the size of age, to know if it matches the number of rows in my data frame, I can use, for a vector, I can use the function length. So length of age. Oh, length is, it's one of those words that if English is not your first language, you might struggle with, the order of the letters. So if you spell it correctly, length of a vector will tell you exactly that, the length of a vector, how many elements that vector has. In this case, it's 3. You can also do length of a matrix or a data frame, by the way, and there what it will tell you is the number of all the elements. So we know that cats is a 3 by 3 data frame. So if we do length of cats, you give 3. I could swear you would give all the number of all the elements, but as you can see, even I don't remember everything that R does. So in this case, I actually don't know what it gives, if it's the number of rows and the number of columns. But I guess we can test it by doing cats2, because cats2 has one more column. So if we do this, okay, so length of a data frame will give us the number of columns. I thought that this will give us the total number of elements, and I almost bet that it does that in a matrix rather than a data frame. So a matrix will be a simpler data frame where all the elements are of the same category. So all the elements will be strings or character vectors or numbers. So I'm pretty sure length does that, but maybe I'm wrong. It's more likely that I'm wrong than R is wrong. Okay. If we want to yes, we already did this. Okay, let's say we want to add a new row to cats, or actually let's add a new row in cats2. Cats2 already has the age column added to it. So first I'm going to create a new row, and in this case I'm going to create a list rather than just a vector. Okay, because I want to, do you remember that when we created a vector of elements of different natures, then you would coerce one into the other. So if you had numbers with characters, you would coerce the numbers into characters. So by creating a list, I can have a series of elements of different categories. Sorry, I don't know. This is okay. So let's create the list. And the first column is the coat of the animal. So the coat of the new animal, the new cat that they're telling me to do is one that I can't pronounce. So I'm just going to write it down. If anyone wants to tell me how to pronounce this, tortoise shell, I don't know. So, but that's what they're telling us that the new cat is. And then it's a 3.3. I think that was the weight. And then we have a logical vector as the third column. And then the last one was the weight. It was the age of the cat. So let's create that list. So I see that Richard came back. Is everything solved?
Yeah, so we've managed to locate my working directory. But so I'll catch up now. Are we still on the same feline dash data? Okay, I will. I'll start with the next when you do the next section.
Okay, so very quickly, what I did was we created the cats, and then we created a cats2 by c-binding a new vector, which is an age vector. So you can create a vector of three numbers, whatever age you want to give your cats. And if you do c-bind, you add a new column to cats. But to create another data frame, you need to do c-bind of cats plus age, and then add that to a second data frame called cats2. And I'm just saying this because we're going to need it. So if I just copy this to the chat, hopefully you can catch up. So now we're going to add a row to cats2, sorry. We're going to add a new row to cats2, Richard. So I was explaining that to add a new row, I could create a vector, but if you remember from last week, a vector will have to have all the elements of the same type. So if you have one number, everything had to be numbers. If you had one character, everything had to be characters. Otherwise, R would coerce the data into one single type. So to avoid that, because every column has a different type in our data set, we're creating a list instead. So we can have a series of things of different types. So we can have numbers and character and strings, etc. So this is all we're doing. We were just doing, making a new list called new row of this new type of coat of cat that I don't know how to pronounce. The weight of the new cat, which is 3.3. Then an element which is a true or false element, and then the last one, which is the age of the cat. So all I did was to create that new list. So now what I'll do is let's try and do rbind of cats2 and new row. And I want to substitute cats2 with that. Okay. So by doing this, I'm assigning the bind to cats2 again. So it's going to replace our original cats2. Let's have a look at that. Right. So it did work. Let's have a look at cats2. It did work. What happened was it gave us a warning message that says invalid factor level NA generated. So what happened here? When we imported the data set saying strings as factors equals true, our first column, which is in fact character strings, so they're words, this was transformed into a factor. And if you remember from last week, a factor, it's like a list where you're putting things into categories. So if we look at just cat2 code, which is our first column, it tells us that it has three elements, and then it has 3 levels. So even if we extended our data set, and if we had, let's say, 10 rows, and everything was either calico or black or tabby, you would still have 3 levels. You would just put each new row into each of those categories. What we're trying to do is that we try to add a new row where the element to go in that column didn't belong to any of these levels, right? So we added a new type of code, and R is like, wait a minute, this is a factor here, and the new element you're trying to add doesn't belong to any of the levels of the existing factor. So when we imported cats, if we had done strings as factors equals false, this column would not be a factor, and therefore we could easily do this without the warning message. And instead of adding an NA, a missing value here, you would have added the tortoise shell value. This can be confusing. Do people want me to explain again? Are there any questions about this? Does everyone understand why it's now a missing value rather than the tortoise shell? Right, I'm going to continue with this, and I'm going to demonstrate how we could have done this by adding a new level of in our factor here. So if we do levels of cat's coat of our column, it's going to give us this, right? It's going to give us that this factor has 3 different levels, the black, the calico, and the tabby. So we need to change that so R can accept our 4th level. So to do that, we will replace this value of the levels. So if we do, what's the best way of explaining this? Let's combine the levels with another word, which is the tortoise shell. So if I do combine, so see, levels. So here I'm having a function inside of another. So I'm doing combine the existing levels of cats coat, right? So combine, the first element of combine is the existing levels. And then the second element I want to combine to that is, and I'm going to copy and paste this word because, you know, I'm going to get it wrong. Right? If your English is better than mine, you could just type it. So I'm just going to combine the existing levels with this new level. So let's have a look at that. If you run that, I now have 4 elements here. But this alone doesn't change the levels of the column because we haven't assigned it to it. So let's add to this line of code here, let's add levels of cats coat and assign. So again, I'm combining the existing levels of cats, and actually I made a mistake. I'm using cats instead of cats2. So actually, let's just add cats2 to all of this. Sorry, this is my bad. Cats2, because cats2 has the extra column. Okay, so the existing levels of cats2 coat, add this and replace it into the levels. So let's run this. And now let's check that again. So let's do again levels of cats2 coat. And now we have 4 elements of this. So now if we want to, let's try and do the R bind again. If I substitute cats2 with an R bind of cats2, and then the list, our list, which was the name was new row. Okay, let's add it again. And now let's check cats2. There we go. So we had the 4th row, which we had previously added, and it had an NA. And now to just show the difference, I simply, instead of replacing this this row, which is of no use because you have as an NA, I just added another one just so you could see the difference. And now we have it correct. Now we added this new value, which belongs to the levels of that factor. So R was like, fine, this matches one of the factors, one of the levels already existing in this column, you can be added. Right. What if we didn't want to change the levels and the factors, we didn't actually want things, we didn't want a column as a factor because it's a bit of a pain sometimes. If you don't need that column as a factor, you might just as well get rid of it because, or get rid of the factor level, the factor and the levels, because it can create issues if you're not wanting to use them. So what you could do is just replace the column with the same column, but transformed into a character type. So to do this, you just use the function as character, and then cats2 coat. So let's have a look at that. So this is just our this is our column, and it doesn't show the levels here, so it's just as a character. And but to actually replace it, then we need to do this, right? So we're taking the column, transforming into a character, and replacing it in the same column. So let's have a look at that. Oh, that's not what I wanted to do. So what I did here is I just selected this and then run it. So you only ran this bit. So we need to run the whole line. And now let's have a look at cats2 coat and see if instead of a factor, it's now a character. So now it doesn't show the levels of the factor. So it's just a character column. Are there any questions about that? Okay, so what if we wanted to remove a row? So let's say that fourth row now, it's a mistake, right? This fourth row was a mistake and I want to get rid of it. We can do another example of subsetting. We already looked at subsetting last week briefly, so let's try that. So if you remember, to subset from a data frame or from a vector, we use the square brackets. And then for the case of a data frame or a matrix that has the 2 dimensions, the first element we write is always referring to the rows, and the second element is referring to the columns. So let's say I wanted to subset the first row, third column. I'll do 1, 3. You don't need to add a space. It's up to you. So if I run that, it has given me the value 1, which it's, if I go here to the first row and the third column, it is indeed the value 1. So it gave me the correct answer. So if I wanted to remove a column, a row, sorry, I'll do cats2, and then I do minus, and then the number of the row. So if I do -4 and comma, this is saying remove the fourth row, all columns, so all elements of the fourth row. I'm not specifying a column. So if we run that, it has now returned cats2 without that problematic row.
Sorry, Joanna, they were asking in the comments, how do you create the NA?
How I created the NA. Okay, so let's go back here. I'm gonna, so now I've done something to my data set. Let me just rerun this bit. To generate cats2, we had cats. Let's have a look at cats. Cats is just our 3 rows and 3 columns original data frame that we imported from our CSV file or created. And to do cats2, I added a new column called age. Okay, so I'm going to just rerun that. So I created a vector age of 3 values, which are the ages of our cats. So if I run that, I've created a vector age. And now to generate cats2, I use cbind to bind a new column to the data frame. So, and then store that into a variable called cats2. Okay, so let's do that. Okay, so cats2 is the same as cats, the same 3 rows and the same 3 columns plus a new column called age. Okay, so this is how I generated cats2 originally. Now, if I wanted to add a new row, okay, I created a list called new row, which had additional values to this that I wanted to add as a new row. Let's say I'm collecting data regarding cats, and I have a 4th cat coming to my study, and I want to add that to the data frame. So I created a new row, and the elements of that new row for my data frame are tortoise shell, which is the coat, and then I have the weight of the new cat, which is 3.3. This column that exists in our data set that, quite frankly, I don't know what's for, but I'm just going with it because it is in the exercise. They don't explain it, why we have a logical column here, but we're going to go with it. So there's a 3rd column called light string, and I'm adding the value true to that, so this is a logical column. And there's the 4th element, it's the age, which is this column that I just created. So this is my new cat. I want to add 2 cats2. Okay, so first I create the vector, new row. I run that. Let's just have a look at new row. Okay, so it's a list. The first element is the coat. The second element is the weight. Then we have the logical element, and then the last element of this list is the age of the age of the cat. Now this only creates the vector of a new row. It hasn't added it to my data set. So to add that to the data set, I use the function rbind, which stands for row bind. So now instead of adding a new column, I'm adding a new row, and I do rbind cats2 and then the new row. And I store that into cats2. So it'll replace my original cats2 because I don't want to create another one. I'll just replace the same one. So let's run that. Now, this has thrown an error message that says invalid factor level NA generated. Okay, so let's have a look at cats2. So cats2 now is our previous cats2, which is 3 rows, 4 columns, but the last row that it added it correctly except for the first element, which should be the coat, tortoise shell, and instead of adding the word tortoise shell, it added an NA. And the reason why it did this is that we have this column as a factor. So if we do cats2 coat, oh, not cats2 cats, this is what I wrote, which is obviously wrong. So it threw a null value because it doesn't have any column called cats. So let's do cats2 coat. So this is a factor of, this is all the elements in the column, and the levels of the factor are black, calico, and tabby. So when we imported the original data set, we added the argument cats as strings. Now everything is cats. Strings as factors equals true. Right, let's have a look at that. So here at the top, when we imported cats, I added this argument, strings as factors equals true. So what this argument does is that goes to the data set and looks for any columns that are strings. So in this case, these are character strings, they're words, yeah, this column, and turns them into a factor. And what that means is that we have like that column full of elements, and it groups them into categories. So in this case, we had 3 rows, and each of them was a different category. We had calico, black, and tabby. So if you think about, for example, if something is black or white, an object that you're collecting, and you have a data set of 10 rows, everything is either black or white, you'll have a long list of things that are black and white. So by turning that into a factor, you still have your list where each element is either black or white, but the levels are two, black and white. Okay, so it takes your characters, your each element separately and groups them into categories depending on their value. Okay, so because of that, our original data set only had three levels, black, calico, and tabby. When you added a new row and you said to R, look, this first one is a tortoise shell, R said, yeah, but that's not an existing level of my factor. So you can't add that element because it doesn't belong to any of the levels. So instead, it generated an NA. Is that clear? Is that more clear?
It's clear, but in my case, it's the other way around. I've got NA in the place of calico, black, and tabby, and I've got tortoise shell.
That's really strange. That's really strange. Do you mind if we can have a look at that?
I'm joining from a different computer, so I would have to join.
Okay. I don't know. I wouldn't be able to tell what you've done. I don't know what happened. Yeah, I'm so sorry. I don't know what could have been. Why is it why it took the new value as the only level?
Yeah, but when I type in cats, it's okay, and it sees all of those, but cats too, yeah, all of those.
Try to do this. So try to do this to add the new row to cats rather than cats 2, and just eliminate this 9. Do you know what I mean?
Yeah.
So, and see what happens there. Because then you'll see maybe the problem is with cats 2, the way it was created or something.
Joanna, it would be, I'm trying to catch up, but I've missed, and I can't, because you scroll through. Would it be possible just to paste the whole of that window you've got there in the chat? So when any of us have made mistakes can try and figure out where they happened.
I'm very happy to slow down if people are struggling, because there's no point in me continuing just following everything, trying to deliver everything if people are not actually following along. So I'm very happy to slow down. If there's any section you want me to repeat, explain again. This is quite important. Manipulating data frames is I think for most people using R, they're going to be doing this sort of stuff. So I'd much rather spend more time in this and explain it again if people want it. So please don't feel, just interrupt me and ask again, explain that section. So sorry, I don't know who I was talking to because I can't see all of you. The person that said about the NAs. Sorry. Has that worked if you added this to cats without the 9?
Let me see. I think so. Yeah, now it's all fine.
Okay.
Yeah.
So I don't know what happened there, but maybe try to regenerate cats 2 or something. But don't worry if not, I'm sure. Yeah.
Thanks.
So I don't know where the NAs came. Richard, if there's anything you want me to repeat, I'm happy to clarify anything.
No, please carry on, because everybody is following. It's just because I missed some and you'd scrolled past. I didn't know what what I was supposed to be typing in. So I've now got it in the chat and I'll try and catch up, but please carry on without me. Okay. I am listening.
Right, so what we did here was, so I hope everyone understood the levels, but again, it's not the easiest concept to understand. It took me a long time to understand levels of factors. So I'm happy to explain again, but the reason why we couldn't add the row initially was because this was a factor, and the levels, the new element didn't match one of the levels already existing in that factor. To solve that, we have several options. One is to just, if we want to get rid of the factors, we don't need them, we could just go back and upload our cats and just change this to false, and there that column would just now become a character string, meaning that they'll just be words without being grouped into categories. Or if we want to keep things as a factor, we could reassign the levels. So we could say, okay, the levels of cats2 code is now the original ones plus this new one. So please add this as a level to our factor so I can then add the row. So that's what I'd done. We looked at the levels, yeah, and there was three levels. We reassigned it so that you would add tortoise shell at the end. And then we check again. And now we have 4 levels. And then we could bind the new row without problems. So if we do that, I now have the original row I added that caused an NA. And then I have a second row, which I just added now because I had more levels. Now I had a new level in. It accepted tortoise shell as an acceptable value of that factor. And now I was showing you how to remove this row that I'm not so keen on having there because it has a mistake. It created an NA. So if I do use the square brackets to subset our data frame, and in the first element I say -4, which is the number of the row I want to get rid of, and then leave the column space in blank, I'm saying remove the 4th row, all elements of that row. So I'm not specifying a single column. So if I run that, I now have the cats2 without it. Now, of course, this hasn't replaced it into cats2 because I didn't assign it, right? I didn't use my assignment operator to substitute that cats2. So if I wanted to do that and get rid of that row completely, I would do cats2, right? In the assignment operator. So now I'm saying to cats2 remove the 4th row and then replace it in cats2. Be very careful doing this sort of stuff because, for example, what could happen here is that you do this, you replace cats2, and then you forgot that you run that code, and then you go and run it again, and then it removes this row. Let's try that. If I run that, and now let's look at cats2. It removed that problematic row. It removed the NA. But if I forgot that I've done it and run it again, and then did cats2 again, it now removed the tortoise shell. So when removing rows or removing columns, I personally prefer to save it as something else, as a separate data frame. So I would call it cats4 or cats5 or new cats or something like that, just so you don't, you might get rid of data without even noticing. So I'm just going to add the new row again, just so we can have it. Okay. And now let's have a look. So now we have it absolutely fine. Now another thing I could do was to do NA omit. Now I got rid of it. So how can I do it? Okay, let's add the new row again. Okay, let's add the new row. Let's add a bit. Oh, now it works because it's not a character, because the levels are there. Let's try, sorry, I'm gonna just do this. I'll explain it. I'm gonna create a cats4, okay, where I'm adding oh, this is not gonna work. I wanted to show how to remove NAs. Okay, I know what's the easiest way. Okay, so let's just have a look at the stage of our cats2. I just repeated a new row. But let's try and add another row where the new element of the code doesn't match any of the levels again. So if I do cats2, I just want to repeat the NA to show you something. So if I do cats2 and then I do C, let me create another row. Okay, C, and then I want, I don't know, brown cat. I'm sure that's not a thing, but brown. Weight, let's say it's 5 kilos, true, and then he has 7 years old. So let's create that another row, and like we did before, we want to do R bind of cats2 and another row, and I just want to repeat the NAs. Because brown is now not an acceptable level, it's gonna throw an NA, I'm pretty sure. And I'm gonna repeat that, and I'm gonna substitute cats2. So let's do that. Again, we have a warning message. Let's have a look at cats2. Okay, so now I have an NA, and I just wanted to show you this because if you have rows with NA in your data, you might want to get rid of them. So one way of doing that is you could use the function na.omit in cats2. Now, this is not just going to remove the NA, it's going to remove the whole row that has the NA. Okay, so R is assuming that your data is entries. Each new data point is a new row. And if you have NAs and you want to get rid of it, it removes the row. It doesn't remove the column. It removes the whole row. Let's have a look at that. So this is cats2 as we have it now. If I run this, oh no, not to cats2, sorry. If I done this, it has now removed the new NA row, and it's removed the whole row. Okay, it hasn't replaced it in cats because to do that I would have to assign it to cats2. So it's always the same story. If you wanted to save it, you have to assign it to a variable. So let's do cats2. The NA is still there, but if I do NA omit cats2, it gets rid of that row. So this is important as well because for some statistical tests you do, R might not be okay with accepting any rows that have NAs, and you might have to do this exercise, or you might have to specify NA omit inside of that function. So just very quickly to show you before we go for a break, how to remove a column. Let's say I want to get rid of the H column now, and it's the same as the row. So as the row, if we want to remove a row, we've done -4 and then all columns. So in this case, I want to do cats all rows. So all the elements in that column. And then let's say I want to remove the H. I can do -4. Sorry, didn't mean to do this, -4. Okay, so if I do that, the age is now gone. So it's the same logic as before, but you're just doing columns instead of rows. So to remove the fourth row, we're done cats -4, all columns, and here we're doing all rows -4. Okay. Right, let's have a 10-minute break. 10-minute break, is that enough for people? I'll stick around if people have questions now during the break, because I know that some of this is a bit confusing.
Joanna, thanks very much for, I managed to kind of catch up, but there's a whole bunch of things I missed in the middle. Yes. I get the idea of some of that, and I'll watch the video back, which hopefully will have your explanation on top of the script, so it'll make sense. So just quickly though, what is the cbind doing?
So the cbind is taking your data frame and adding another column. So cbind.
Okay, so it's binding a column, right? Okay, that makes sense. And then I got as far as trying to add the tortoise shell, and then it all went horribly wrong after that. But I kind of get the idea. I missed the bit about the NA, which is, but I'll get that off the video. Then I think everything else in the first part was okay. Are you going to save this all of your script somewhere that we can go through it?
So what I've done in other courses, when people ask, I don't do that by default, but I'm happy to do it, is annotated with comments. So with the hashtag, just comment the code so you know what you're doing and then send it. I don't have your emails, but I can send it to Debbie and hopefully she can.
Yeah, I think so. Because I was spent the first 5-10 minutes even just trying to get the feline data to load. So basically, I'd last week, I think on the Mac, you'd sent us to using the kind of the Windows-based thing where it says set. You can find your files inside the file window. And so because then I missed all the stuff, it's impossible to kind of try and do that while then also following what you're doing, because the window is actually quite small as you're typing it. It just disappears very quickly.
Yeah.
So I will. So no, it's not your fault at all. Thanks for your patience. But I'm sure with the video, if I can get the Zoom recording from Debbie as well, then I will be able to go through it. So that's great. Okay. I'll let you go and have a break. Thank you.
I repeated a bit, so I'm sure you'll catch up.
I got most of it. So it's just
around is the NAs, but I think I explained that twice. And if you don't understand that bit, it's not hugely essential either. I should have said this to people.
Well, I was doing a little bit of graph plotting during the week, and there it was kind of important as well. So I think that actually is quite important for me. So I'll make sure I understand it, and if not, I'll I've got various people around me who know what they're doing as well to help. So thanks very much. I'll let you go and have a break.
No problem. Yeah, Laura, don't feel like you have to stay here. I just thought I should. I might switch this off for. I don't even know when I said 10 minutes. Maybe it was 5. Was it 5 past?
Yes, it was just a couple of minutes ago. Yeah.
Mm-hmm. I'll just stop sharing for a bit here. To show you how we subset vectors as well. So we've been using the square brackets to subset we've been using the square brackets to subset data sets and matrices. And now I wanted to quickly show you how to do it with vectors. So let's create a vector called x and using the function c. I'm going to put together a series of words. So let's do banana, hat, snake, and ice cream. So we have a vector with 4 elements, and they're all character elements. So let's look at X. Yeah, so it's correct. So let's say I want to subset the two values of the first two values of X. I could do X square brackets, and now I'm not using a comma because X is a one-dimensional vector, so there's only the indexes are only either 1, 2, 3, or 4 because it has 4 elements. When we were looking at matrices or data sets, we had 2 dimensions, right? So we had the rows and we had the columns. So if we wanted one single element, we would have to give it a row number and then the column number separated by a column, by a comma, like we did here. Here, I only have to give it one number. So first, let's say I wanted just the first element of the vector. So I'll do 1. Banana, that's correct. Let's say I want to do the 1 and the first and the second element. I can do X 1, 2, 2. Okay, so we use the colon to do 2, 2. We've done this last week as well. And now we have the 2 first elements. Let's say I want the first 3 elements, and I'll do X 1, 2, 3. Yeah, and now I have the 3 first elements. And like we did for the data set, the data frame, I can also exclude elements. So let's say I want to remove the second element, which is the hat. So I can do X and then -2. And here I have my vector without the second element. So most of the principles of subsetting like that we used for data frames and matrices, they'll apply for vectors as well. So I wanted to show you this. Right, let's move to something completely different. Let's look at the control flow. And what I mean by that is that if you want to do the same action repeatedly, or if you want to do things with a condition, so let's say if a number is bigger than 10, I want to calculate the mean of this row, or if a number is smaller than 10, I want to calculate something else. You can code this in R and add all this different conditions. So let's look at if statements, and if statements are to help us make a decision on whether to perform a task or not based on a condition. So what is the structure of the if statement? And now what I'm going to type is not exactly, it's not code that will work, it's just a way of showing the logic. So the structure of the if statement is as follows. If, and then inside of the normal brackets, I write the condition. So condition is true, right? So if whatever is inside of the brackets is 2, then I perform an action. And the action goes inside of curly brackets, okay? So this is the structure of the if statement. If condition is true inside of brackets, I perform a task which is inside of the curly brackets. So perform action. Yeah. So this code won't work, obviously, because this is just words. So I'm going to comment that out, but it's just to illustrate what the logic is. So let's create a very simple if. Let's say that if X is bigger or equal to 10, so equal or bigger to 10, right? So this is what this symbol is. Then I will perform the task of printing this sentence, print. And inside of the print, I write X is greater or equal to 10. So I'm fully aware that I wrote X by now. My X, it doesn't have anything to do with the X here. Let's create another X. Actually, let's change the letter. Let's create a Y. Okay. y is a number. Let's say y is 8. Okay. So first we determine y, and then we say if y is bigger or equal to 10, then print y is greater or equal to 10. Let's run all of this. Right. It didn't work. Why didn't it work? Because it ran the if statement, but because y is smaller than 10, it didn't print anything. So let's change the value of y to 12, for example, and let's run this now. First I run the y. Now my y is the value 12. And now I run my if statement. And now the if statement return y is greater or equal to 10 because y is in fact greater than 10. So this is a simple if statement. Let's say we want to add otherwise. So if this, then do this, otherwise do that. Okay, so I want to add an alternative action. And for that, I add else. Okay, so let's do if, the same as above, y is bigger or equal to 10. Okay, so exactly the same action. Sorry, it's bigger, not smaller. So if y is bigger or equal to 10, I'm going to print y is greater or equal to 10. Okay, so it's same if as we had here, but now after the curly brackets, I'm going to write else. Okay, so otherwise do this, else, and then open another curly brackets to input another action. Otherwise, so else, print y is smaller than 10. Oh, but it needs to be in between quotation marks. That's my bad. Okay, so let's look at this statement. If y is bigger or equal to 10, I'm performing this action that's inside of these curly brackets, which in this case is print y is greater or equal to 10. Otherwise, if y doesn't meet this criteria, else I'm doing this action, which is print y is smaller than 10. So we know that y is 12, right? So let's run this. And now it returns y is greater or equal to 10, which is true. So let's move y back to being 8 and see how that changes the exact same code we just created. So first I run this. Okay, so I have updated my value of y. And now I'm running this. And now y is smaller than 10. That's the result. So the exact same code, it return a different output based on the value of y changing. And this is why the if statements and if else statements are powerful, because you could write code to do something multiple and multiple times and just changing the value above and then changing the action you're performing based on the value changing. Yeah, are there any questions about the if statements? I'm going to add another layer of the if statement, which is, let's add yet another condition. So let's say if y is bigger than 10, if y is bigger and equal than 10, that's the one, I am writing y, so exactly the same as above, y is greater or equal to 10. Now I want to say if it meets this criteria and it meets another criteria, which is y being bigger than 5. So if it's bigger or equal than 10, no, sorry, if it's sorry, what I want to add is another else if the condition isn't met, right? So if y is bigger or equal than 10, print this. If it's not, then it can only be smaller than 10, which is why we added the else here. But what if to this else, I want to add another condition? I want to say else if, and then say, else if, and then I need to add the condition, which is y is bigger than 5. So what I'm saying is, if y is bigger or equal than 10, I print this. If it's not, then it must be smaller than 10. But what if it's smaller than 10, but bigger than 5? Then I'm adding another action. So I'm saying, if y is bigger than 5, print y is greater than 5, but smaller than 10. Okay, so now I have another condition. And then to finish, else. So if it doesn't meet this, but it doesn't meet this as well, so if it's smaller or equal to 5, then print y is equal or smaller than 5. So let's run through it again. If y is bigger or equal to 10, y is greater or equal to 10. That's the statement I'm outputting. If it isn't bigger or equal to 10, it must be smaller than 10. But what if it's smaller than 10, but bigger than 5? So I'm adding this condition to check the value again. If that's the case, it prints y is greater than 5, but smaller than 10. Otherwise, so that's all the other cases, the last else is all the other cases, y is equal or smaller than 5. So let's run that. Let's remember what the value of y was. That was 8. So if we run that, the output is y is greater than 5, but smaller than 10. If we change the value of y to, let's say, 4, let's run that. Run the exact same if y is equal or smaller than 5 now. So now we've moved to this condition being met here, the last else. And this can get as complicated as you want, because you could just add ifs and things like that. Are there any questions? If you just want your if or else to be very simple, like the one we did before, either it meets this condition or not, then you can actually use a function instead of the if statement with the curly brackets. So in that case, if it's a very simple if statement, if or else, we can use the if else function. So let's try our first scenario, which was either x is bigger or equal than 10 or it's not. So, and the structure here is, first you have the condition, then you have the first output, and then you have the alternative output. So let's say y is bigger or equal than 10, smaller or, sorry, it's always bigger or equal. Why am I? Y is bigger or equal than 10. If that condition is met, you say it outputs y is greater or equal to 10. Otherwise, right? So comma, and then you put the otherwise action. Y is smaller than 10. So this is the most simple scenario, and if you have that, you could just run this function. So in this case, y was, if I remember correctly, 4. So y is smaller than 10. If we update the y value to 11 and run it again, y is greater or equal to 10. So these are just a few options of how to use the if statement. But what if you don't want to use an if statement, what you want to do is to repeat the same thing over and over again, over different data sets, different files, different rows of one data set. So instead of having to repeat, to have your chunk of code and then having to go back, changing all the variables and all the file names and run it again, then do it again, then do it again, and having 1,000 files with the potential of creating a lot of errors, because every time you have to go and change the file names, you might make a mistake, you might put the wrong file, and then you might not notice in the output, and then that it's not very reproducible. That's what I'm trying to get to. The more you have to change to repeat the same task, you have to change things over and over again, the more problematic your code becomes, and more chance you have of making a mistake in your analysis and not making your analysis very reproducible. So ideally, what you can do is to write things like for loops or functions that are capable of repeating the same tasks over and over again. And all you have to give it is one little input that you can change very quickly and very easily. And it's very visually, it's easy to visualize what that is. So if you need to check your code and fix it, then you can do that very quickly. So let's look into for loops, which are very useful for that. And here, similar to the if statements, we are using curly brackets to perform an action. But instead of the circular brackets, the parentheses, what you're writing is the things you want to iterate through, they want to move through. So the structure of that is for loop, and then inside of the normal brackets, you have iterator in set of values. So what could this be? Let's say you have a list of 10 different files you want to do the same analysis on. Then the iterator is basically the current file you're on. So file 1, then file 2, then file 3, then file 4, then file 6, etc. The set of values is the list of all the files you have. So the for loop will first take that first value, so the first file on your folder. Then you'll perform whatever task it comes. Then you'll go to the second file, perform the exact same task, third file, exactly same task, etc., etc. So the iterator is your current loop, the current file or the current value you're working with at the moment. And the set of values is the list of all the files you want to have to, all the values you want to go through. And then inside of the curly brackets, you have the action exactly like you did in the if statement. So perform an action. Okay, so this is the structure. I'm going to comment that out because it's not proper code, but that's the structure of a for loop. So let's do our first for loop. Let's say that I have, for the values of 1 to 10, each time it iterates through the loop, I want to print that value. Okay, so for inside of the brackets, I have my iterator in the set of values. So the iterator, you can call it whatever. It's just a temporary variable you're using. So the norm is to call it Y and then J and then whatever, but you can call it whatever. You can call it Birmingham. Like it doesn't matter. It's just a temporary variable you're creating. So let's do it with Y, and then we'll change it just so you can see that variable, what I mean by that. So I in 1 to 10. So we already saw last week that this column here is going to create values of 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my iterator in the set of values. And then inside of the curly brackets, I'm going to simply put print I. So I is my variable. Let's run that. Okay, So each line of code, it means that it run the for loop all those times. So the first for loop gave the output 1, the second loop gave the output 2, and so on until 3, until 10. But what I meant by when I was learning for loops, what really confused me was the I. What is the I? I'm not defining the I, but the I is the temporary variable. So the for loop, the I will take the value of 1. And then on the second loop, the I will take the value of 2, and then etc., etc. So if we change this name, this variable, to whatever we want, it'll still work. Let's say I'm calling it Birmingham, like I said before. This is just a variable name. Then I have to replace it here as well. Yeah, so if I run that, it's still going to work the same way. So it doesn't matter what the I is. The I is just people tend to use I, but you can use whatever works for you. I always found the I confusing, so I wanted to explain this bit. So you can also put a for loop inside of a for loop. Okay, so let's say that you have a list of files, okay, and then each file has 3 columns, and each column is a set of values you collected, and you want to analyze them separately. So now not only you want to perform a task in each single file, but inside of the file you want to perform that task separately 3 times. Okay, so you want to take the first file, perform the task, whatever calculation you're doing, in the first column, then perform a task in the second column, then perform a task in the third column. Then you want to move to the second file, first column, second column, third column, then the third file, etc. That means that you have to iterate not only through the files, that's the outside loop, right? But inside of that loop, when you're in file 1, when in your the iteration number 1 of the outside loop, you also want to iterate through the columns of the file. So you're going to have 4 loops, an inside loop and an outside loop. So let's try and do that, not with files, but hopefully it'll make sense what I'm talking about. Let's create the outside loop. So if you keep this image in your head that the outside loop is iterating through files, it's exactly the same as we just did. 1 to 10 or 1 to whatever number, we're iterating through all of those elements. So let's just start with that. Let's generate another for loop. And in this case, I want to do again I in, and let's do 1 to 5. So it's a bit quicker. So again, I here is just going to iterate from 1 to 5. And then you open the curly brackets and you perform the task. Now, for each of these elements, 1 to 5, I want to create another iteration. So let's say we have 5 files. First file, I want to create an iteration through the columns of that file. So now I need to put a for loop inside of a for loop. So for, and let's say now it's J. So as I said, usually people go from I, the second iteration is J, but you can, again, you can call it whatever you want. J in, and now let's do a vector of several letters, okay, just to illustrate the point. So let's do A, then B, then C, then D, then E, and that's it. So let's just have a look at what this vector generates. So I just highlighted this to output, and there's a vector of A, B, C, and D. So J is going to iterate through these values. So the first iteration of J will be A, the second iteration of B will be B, of J will be B, etc. And now I perform the action. So note that I'm closing this for loop here, and then I'm closing the outside loop there. So this curly brackets closes this for loop, and this curly brackets closes this for loop. So the action I want to perform is to paste the value of I with the value of J. So I want to, for the first outside loop, it's 1. And then for the first inside loop will be A. I want to paste 1A. Then we're iterating inside first. So the next value will be B, still on 1. So I want to paste 1B. The third value of the inside loop will be C. So then I want to paste 1C. So to do that, I use the function paste. And then I need to do print first, so it shows. Paste I with J. So let's run that. So this is the output. So if you remember, the outside loop was the 1, 2, 3, 4, 5, and the inside loop was the A, B, C, D, E. So for 1, you went through all the letters first, then you moved to the second outside loop and you run through all the letters again, then to the third outside loop and you move through all the letters again. So let's imagine the numbers are the numbers of files, like in the analogy I was using, and the letters are the columns in a file. So in each file, there's the columns A to E. So you picked up the first file, and for that file, you analyze the column A, the column B, the column C, the column D, the column E. Once that was done, you move to the second file, you analyze column A, B, C, D, E, etc., etc. So you can nest, it's called nesting. You're nesting one for loop inside of another. Are there any questions about that? While I make a quick decision of where to go next, because we only have 15 minutes. Or I can explain something else from today or from last week again, if people have any questions. I can also do that. Or I'll just keep adding to the for loops.
Can I ask you a question, please? I'm just wondering, let's say you got the data from 1 to 10, and what should we do if we want the program to run from 1 to 5 only, but not doing 1 to 10?
Yeah.
So under this situation, what the loop should look like?
So you don't have to include all the elements. Let's say you're listing all the files in your folder. You don't have to, the for loop doesn't have to run through all of them. You need to find a way of telling the for loop to just do the first 5. So that could be because you named them in a certain way. You named your files with the numbers 1 to 10. And then you can, in your for loop, specify that you only want to do it from 1 to 5. Or you could, yeah, you could do it like that. Or you could name, or if it's like H to whatever letter, you can also just say, instead of doing 1 to 5, you could create a vector, let's say C, where you're creating file 1, yeah, and then file 2, and these would be the names of the files, for example, file 3. And I'm saying files, and it can be any elements of a list, or, right? So you could iterate through files, or you could iterate through data sets or whatever. Yeah, so you could just make this 4, and then file 5, right? So you're creating a vector with the names of your files or of your elements. And then instead of having 1 to 5, you replace it. Let's do copy. I'm replacing the 1 to 5 here by my vector. So now I is going to take the value of file 1. Then you'll take the value of file 2, then on file 3, file 4, file 5. So let's say you have files 1 to 10. You don't have to include them all in your for loop. You just need to make that very clear. This is the important bit, is that the list of things you're giving to the for loop to iterate through. You don't have to give them all of your 10 elements. You can just give 5, just make that clear.
Then how about the situation where, let's say there are 10, 1 to 10, okay? But if we want the program to do, like say, just print the even number, like say 2A, B, C, D, E, 4A, B, C, D. If this is okay, then what should we do?
So you'd say that you have elements 1 to 10, but you only want to do the for loop for 2 and 4.
Yeah, even number. Yeah, even number. Yeah.
Let's say, let's remove this. I can just do, the way I would do it, there's different ways of doing it, but I'll do C, 2, and 4. Okay. So now you're saying only for these 2, run it. Oh, there's something I added. What is it? Something wrong. There's a parenthesis here that it's extra. Sorry, this curly bracket should be here. Just want to be clean. So let's run that. So now it just run to 2 to 4. If you just want the odd numbers, there's ways of doing that. Let me just quickly think about our odd numbers. I have to Google a lot of things.
But in this case, we have to specify it is 2, 4, 6, 8, 10, something like that.
Yeah, or you could say, or odd numbers of that. Let's say if there's I'm just checking if there's a function for that. There might be a function where you could do the function and then 1 to 10 and just take the odd numbers, for example. Yeah.
Okay.
This is the important bit, is the vector you give R to iterate through. That's what you need to be changing to just get those values. Right. Is there any other questions? Another way you could do that is give it 1 to 10 and then put an if statement inside. For this vector, if it's odd numbers, do this, else do something else.
Right.
So there's different.
But it would be very time consuming. Let's say I have more than thousands or 10,000 observations in the data set. Then I will have a difficulty, because if I type 2, 4, 5, it's very time consuming.
Yes, so you can
any command to say I want the even number, and then the program will execute it.
This is what I'm trying to find. There's a function for that. I'm just trying to remember what it is. I think it's sec. Let's try it. There's a function, I think, which is called sec. And then let's say 1 to 10. And then comma 2. I think this means every 2 numbers. No, it doesn't. From 1 to, I think. Okay, so I think it's like this. Comma. From 1 to 10, every 2 numbers. Let's try that. Okay, so this starts with the 1. So if I do starting on the 2, I'm doing the odd numbers. Again, there are surely more complicated ways as well to do it. If you want to be more specific, you could do that. You could do it to 100, and then it's giving you every 2 numbers, 2, 4, 6, 8, 10. Then you could add this in your for loop here.
Yeah, I get it. I get it here. Thank you so much.
Another thing, we don't have time to do today, but if you start having tasks to perform in a large number of files or of data sets or things, you can write functions. You can write your own functions. So we've been using functions that already exist in R, but you can write your own function. And that's even more efficient many times than for loops, because even though I love for loops, they're very useful. As you say, if you have a huge data set, it'll take forever to iterate through all of the things, because it'll do one at a time. Whereas for a function, you can actually make it complex enough that you can parallelize it in your system. You can run it in multiple files at the same time. So it's a matter of finding that efficiency balance of time versus memory, computer memory, etc. But you can get really complicated. The R course teaches functions, if I'm not mistaken, but we didn't, yeah, there was no time to go.
Joanna, can I ask you a very basic question?
Yes.
So I keep getting the situation where I've obviously made a mistake and my console window at the bottom is not giving me the square brackets 1. And this, how do I can press an escape and it gives me the 1 back again? Or no, it doesn't. It's just basically in the middle of some kind of crazy loop.
So you have a plus. Do you have a plus?
No, I've got a greater than. And it doesn't matter what I do in my top window, it just doesn't give me back my 1.
So you have.
So I need to kind of reset it.
You have this symbol.
Yes.
This symbol is fine. This is waiting for input.
So if I then try and enter something really simple, like I've said, y should equal 10 above that, and then put y in, it doesn't tell me that it's 10. Or it does. Oh no, it's working. Now it's working. Okay. So if there's an error in the top section,
yes.
What is the way? How do I know that that it's gone? That I need to get back to the start, like to reset it? Do I just press escape or something?
I think it is escape in the Mac. I'm not fully sure,
okay.
But I'm pretty sure it's escape as well. Let's try it. That usually happens when you haven't closed the bracket or something.
Yeah, and then it's printing what I'm typing in the top window, then prints in blue on the bottom window, and that's basically showing me there's an error, right?
Well, for me, shows as a plus that doesn't go away. Let's. I'm gonna get rid of this bracket here, so I'm not closing the loop. RStudio is actually telling you here there's a mistake, unmatched opening bracket, but it doesn't always do that. And if you're using R without RStudio, it's certainly not going to do it. So if I do this, I haven't finished. So R is still waiting for input, so it's plus.
Okay, that's what
I can't do
it
now unless I do escape.
Okay, thanks.
Yes. That's usually a bracket that hasn't been closed, or sometimes it's a couple of brackets. So you might have to press escape several times, or like commas, misplaced commas. I don't think that gives a plus, but it also gives you an error. Those are the most common mistakes. I once spent an afternoon looking at a code without being able to tell where the error was. And then by 7 p.m., I realized it was a misplaced comma. So that can happen very, very, very frequently. Right, there's 5 minutes to go. So I'm not gonna, everyone, my brain is fried and I presume you're all tired. Thanks for staying. Please remember to do the feedback. I'm going to paste it again. The link, I think Debbie might email you. I'm going to ask her to email you these 2 tutorial scripts. If you don't want to use them, don't use them. But I'll annotate them. So it might take a couple of days because I'm going to put comments on this so you know. But what I wanted to say is that if you go to the website of let me open it. The website of the website I created for the course, you have the sections we went through with all the explanations. So everything I explain, or most things I explain, are here, explained in text, and it explains really well. So you can always look through the sessions again. And the last thing I wanted to mention is that software carpentry has a lot more than what I talked. So just in R, you have 2 different courses. One of them we've been following, but it has way more sections than I could do. So if you want to learn more, please go. I didn't do any plotting, obviously, but you can always learn more. You can learn Python, Git, the Unix. So it's a really great resource to have. And the tutorials are really well explained. So you don't have to have someone coding alone like I did. You can just follow yourself if you make the time for it. I think that's it, unless Laura or Debbie want to say anything else. Debbie's not here, so I'm going to have to tell her about the scripts. But yeah, thank you very much, and I'll let you go. And see you another time.
Great, thank you very much. Thanks.
Thank you very much. It's been absolutely great. Thank you.
Thank you.
Thank you very much, Joanna.
Thank you, Lara. Thank you so much.
Thank you, Joanna. Bye.
Thank you very much, Joanna. Thank you.
Thank you. I need to